Thank you for attending today's webinar co-organized by Singapore Water Association and Fluence Corporation. Today, we will start with a welcome address by Mr. YONG Wong Jin, CEO of Fluence Asia. With more than 30 years working experience and 20+ year management experience globally and more than 10 years experience in water and wastewater construction, oil and gas industry. Mr. Yong has joined Fluence Corporation since 2017 as GM of Fluence China from the beginning of the group. We are glad to have Mr. Gilad Yogev, Senior Product Manager of MABR Products at Fluence Corporation, where he leads products and technology development, MABR promotion, smart marketing, and business development. He graduated from the Israeli Institute of Technology with bachelor degree in environmental engineering and is experienced fields of wastewater engineering, nutrients removal, resource recovery, and reuse to speak on delivering sustainable water solutions through decentralization. Then we will have a 10 minutes Q&A segment. Before we end the session, Before we proceed, I would like to touch on some housekeeping rules and disclaimer clauses. To ensure better connectivity, please mute your microphone and turn off the camera. You may communicate with us after the event. Please share your questions in the chat where we will try to provide answers where possible in the Q&A segment. Do identify yourself so we can respond to any unanswered questions. We'll be recording this session and reserve the right to the video. Please complete a post-event survey, which upon return, we will forward the recording and presentation deck to the respondents. All information shared is for general information only and does not contain or convey any legal advice or administrative assistance. Information shared today is true and accurate as of publication date. The organizer and speakers reserve all rights in the provided materials. Without further ado, may I invite Mr. YONG Wong Jin, CEO of Fluence Corporation, to give us the welcome address. Mr. Yong, please.
After 2020 to all. My name is Wong Jin for the thanks and gratitude and for influence the platform treating our decentralized technologies. These are industrial waste. We would present through and acknowledge the Fluence USA and that with our network of markets, Europe and Asia. In Asia, Fluence China leading Fluence MABR global production. Countries in and Liao. Presence, competitive and strong funding and technology. We are highly. Thank you very much. Presented by my colleague.
Thank you, Mr. Yong. May we invite Mr. Gilad Yogev to share?
Okay, thank you very much. Right, thank you. So, hi everyone. Thank you for joining me today for this webinar on delivering sustainable water solutions through decentralization. I'd like to thank the Singapore Water Association team for a well-arranged event and also the opportunity to present. And hopefully you'll have many questions in the Q&A session right after this presentation. So let's get started. So as water professionals, we all know that many people worldwide lack safe access to water, drinking water, and sanitation. That was in my mind when I decided to go and study environmental engineering, and is probably in every one of our, in all our minds' awareness. But what we aren't quite aware of is the scale of this problem. So the world's population as of January 21 is 7.8 billion people. According to the UN, 2.2 of them lack safe drinking water, and 4.2 billion of them lack safe sanitation. That's 1 out of 3 and 1 out of 2. Obviously, if you're sitting in an office or at home and listening to this webinar, you and your fellow employees or family probably don't suffer these problems. But what that does mean is that huge communities, billions of people, both in developed and developing countries, do. The world's population is constantly growing, and by 2050 will reach 9.7 billion people. This growth is expected to double the global water consumption and worsen these water and sanitation problems. The combined population growth with the increasing water demand are expected to cause a global water deficit of 40% by 2030. 2030 is only 9 years from today. So in a more local perspective, here's a chart of sanitation coverage in the UN Sustainability Development Goals subregions of Asia and the Pacific. The yellow to orange describes areas with a limited lack of sanitation. As you can see, easily see there are problems on the right side in Oceania, for instance, but even the total 22% that have a limited to lack of sanitation in Eastern or Southeastern Asia, for example, that means that 1 out of 5 people lack safe sanitation in a population of over 2 billion. The rural areas typically have a lower degree of safely managed sanitation, and it has many reasons: historical underdevelopment, governmental urbanization policies, funding difficulties, unplanned or uncontrolled construction without proper infrastructure to support, many reasons. A drop of clean water in areas lacking sanitation will always go to drinking. But what happens after that? So the true future of water, as we at Fluence believe it to be, is circular, just like how Mother Nature meant it to be. From the source water, in the desal era, some say produced water, through water treatment, safe water delivery, to smart and efficient water use. But what happens when the water goes down the drain? Well, we all understand that we must treat wastewater. But what we don't always understand in practice, however, is the reuse and return to nature. We tend to use terms like discharge, outfall, outlet, effluent, just get rid of it and make sure we don't get fined for any violation of the discharge standards. But when you look deeper into the concept and remember that the water cycle is a closed loop in our atmosphere, you understand that reuse and return to nature are much more correct, sustainable, and holistic strategies to manage the end link of your water change cycle. As humans, we always strive to achieve the highest goal, right? Conquer the highest mountaintop, achieve the toughest goal, reuse water, let's make it all drinkable. But today, out of the total percentage of water being reused, only 10% goes to direct potable reuse, and the rest to agriculture, groundwater recharge, toilet flushing, and other non-potable reuses. That, together with more than 80% of the global wastewater being discharged with no treatment at all, presents a huge opportunity to boost wastewater treatment and to reuse and solve the global water deficit problems. Reuse is a solution to the water problems not only in developing countries, but also in rural areas or new and expanding cities. Infrastructure is the #1 cost in expanding water and wastewater systems, or in construction of new centralized plants and pipelines. Minimizing it and designing smaller systems for water reuse leads to more money available to invest in robust, sustainable plants with better final treatment and higher quality reclaimed water. These small decentralized systems produce high quality effluent and can be an important part of the solution to the world's water problems. But to properly define the solution, we first have to properly understand the problems of the existing situation where we have large, intensive, and centralized plants. So this is a map of a region in southern Spain called Extremadura, a rural area with beautiful mountains and forests. It has a total population of 80,000 people, with small towns and villages from 200 to 35,000 people. The villages are connected to a large centralized wastewater treatment plant through a vast network of pipes and pumping stations to overcome the hilly terrain. To get an idea of the system size, the distance between the most southern part to the treatment plant is 80 kilometers in a direct line. Now imagine an 80-kilometer long sewage pipeline. In terms of capex of centralized systems, we tend to think about the treatment plant as the largest investment. It is indeed a huge operation that is slow to build and expensive to maintain, but when you zoom out and look at the big picture, it's even more amazing. Sewer networks and pumping stations take up an astonishing 2/3 of the total capex required, while increasing the system energy demand by 50%. The maintenance of these pipes and pumping stations is extremely expensive and complex. It requires professional and trained personnel and increases the risk of failure and leaks. So the severity of an incident, once occurring, can be catastrophic. Think of a large pumping station that is broken down or a major leak in the main sewage pipeline. An alternative to this setup is a decentralized design. So small decentralized plants spread throughout the region would lower the capex and be scalable upon need. You don't need to invest in a 30-year lifetime plant, including all the concrete works, roads, basins, buildings, etc., if you can only add a single treatment container every 5 to 10 years. Capex can be spread over time using smart business models, and the produced water can be sold to local needs, contributing to a more sustainable approach and supporting circular economy. You can also eliminate most of the pipeline and pumping station costs. No large pipes, no extensive maintenance, no expensive infrastructure replacement. Treated water is close to the source and can be reused locally. On the operational side, you may think that a large network of small treatment plants adds to the overall risk and takes up more attention and resources from the water utility. As a matter of fact, you're actually spreading your risks, minimizing the outcome of a failure incident and adding to the overall network resilience. By having smart plants that can be remotely operated under one central control room, you're low on maintenance as well. The water utility can maintain upon demand and reduce operation costs significantly. No need for the usual operator daily checkup, but send your operator in when he is really needed. In a sustainable point of view, plants can be operated on renewable energy since they require much less energy, and can be shut down during no-flow cases, for instance at night. On the energy side, Fluence's MABR-based wastewater treatment solutions can provide significant energy savings, up to 90% less on aeration energy, with very little and negligible pumping energy. But we'll get to that in a moment. Overall, the picture is clear in rural areas. One big, expensive, labor-intensive network with little water reuse versus a large network of small, cost-effective, energy-efficient plants that are easy to scale, expand, and maintain. A small investment is required when building the plant, and scaling up comes with the advantage of just-in-time capex. This is especially important for small communities, which rarely have the capital to invest in large systems and can benefit from reused water for irrigation and other needs at attractive prices compared to tap water. The future of wastewater as we see it in Fluence is with decentralized plants focusing on savings in 4 areas: capex, energy, operation, and maintenance. The decision is a no-brainer for rural areas, but what about those dense populated areas, those huge cities, as in many areas of Asia? Cities were the first to adopt water and wastewater treatment. From ancient Rome to the first modern sewer networks in London after the Great Stink of 1858, years of aging infrastructure lay under city sidewalks and roads, and since cities are always growing and expanding, the burden on these systems sometimes becomes too heavy to carry. But instead of connecting new neighborhoods to the existing old and aging network, why not divide and conquer? The decentralized approach again comes in handy. Small networks can be designed for a longer lifetime and scale as the city grows. Local water treatment and management, reusing the water in the neighborhood for local needs, and returning the rest to green areas or nature. Those can contribute to a more efficient and sustainable system. So we don't need to remove, do we need to remove the old network to fit in a new decentralized one? Apparently not. Centralized systems can use collection pipes laid in a piping overlay, a common practice in many small pinpoint centralized network fixes. That way you can bypass the existing network instead of upgrading, saving the immense amount of money required to dig up and replace old and decaying pipes. Pipe diameters are smaller due to the reduced flow compared to large centralized pipeline networks, and the deployment is fast, simple, and can be gradual according to the implementation timeline. So to sum it up, decentralized treatment systems are the only solution. Install these small, off-grid, renewable energy powered systems and reuse the water as a resource for the local community. For expanding cities, start out with a decentralized approach. Create new, independent, sustainable neighborhoods which keep the resources and labor local. To summarize, let me show you a short video. If for some reason you couldn't hear the video, let's go on. Sorry for that. Okay, I'll share the video later through the chat. You'll all get a link to it. So it's available on YouTube and wherever you would like. And I've spoken about the decentralized approach for some 15 minutes. But to prove I'm not the only one in the world speaking about it, here's some global examples. So China, sorry. Jumped away from the slide. Here we go. China, in its 13th five-year plan, targeted wastewater treatment in most of its 130,000 administrative villages. Many end users in China from the industrial and commercial sector are seeking to reuse water in a sustainable way for their needs. In the US, the Environmental Protection Agency has provided guidelines for decentralized treatment systems for the past 20 years. Sydney Water, one of Australia's largest water utilities, has issued a policy for sewage mining, a concept where the utility pays per liter for reclaimed water drawn or mined straight from the pipe network and treated in a small system. This is a creative approach which greatly supports a decentralized agenda. Several ISO standards have been written lately to support the decentralized planning, focusing on the cost side. The figure on the bottom right side is from a study performed in Jordan that presents a life cycle project saving of more than 35% when going decentralized. However, the main driver for upgrading old and poorly functioning treatment plants is still the regulatory environment. Recent changes in wastewater regulatory environment in China and the Philippines have driven many plants to consider upgrades. These new standards, set back in 2016, became effective during the past year and took a different approach to regulating wastewater treatment and effluent quality. Instead of issuing plant or area-specific permits like in the US, or having different regulations per plant size or population equivalent like in the European Union, all plants need to adhere to these standards. Many small plants discharge bad quality sewage just because they can, which largely contributes to the pollution. And those should be treated the same as larger plants, considering the negative combined effect. So we're convinced that decentralized is sustainable, good for the environment, and will result in a better quality reused water. But does it make sense when you look into the numbers? So our CTO, Ronen Schechter, did a cost analysis on a small neighborhood in a town in northern Israel, where he just happens to live in. The current sewage collection and treatment setup processes around 900 cubic meters per day and has 3 main pumping stations with a total of 4,100 meters of piping, conveying the sewage to a centralized treatment plant. But what would the decentralized approach look like? Three small plants, each 300 cubic meters per day, taking advantage of gravity for flow collection, would have eliminated pumping and energy completely. Remember, that's 50% less on OPEX. Pumping and piping reduced the initial CapEx by 2/3, resulting in a $134,000 installation cost benefit and a $442,000 life cycle cost benefit. This is money that can go back to the community rather than being invested in fixing leaks in concrete pipes or holding huge maintenance crews. This is another example of a study on CAPEX and OPEX, this time focusing on technology. Traditional centralized plants are in many cases conventional activated sludge or A2O plants. MABR offers a significant energy saving on aeration, and when combined with decentralized design, it can reduce both CapEx and OPEX, saving on life cycle costs. So let's learn more about Fluence's decentralized solutions. On the wastewater treatment side, Fluence provides MABR-based solutions. MABR stands for Membrane Aerated Biofilm Reactor and is an uprising and disrupting technology in the wastewater treatment world. Solutions can compact in a container, those are called a spiral, or as an MABR tower, which can be installed in existing or new concrete basin SUBRE. Smart water treatment for small communities is also available through the NIRO box, providing high-quality drinking water from almost any water source. So here's the MABR product portfolio. Solutions can start from up to 5 cubic meters per day, the micro, 50 and 120 cubic meters per day package plants, the spiral S and M, which you can see on the left side. And you can also have building blocks for larger plants, the spiral L, which you can see on the left side, the one with the 3 green circles, the green MABR modules inside. Modules can also be sold as standalone units to be implemented inside existing or custom designed basins. For larger flows, 1,000 to 100,000 cubic meters per day approximately, we have the SUBRE technology, an MABR tower that can be submerged inside existing basins or taken as secondary treatment for a new greenfield plant. To better understand the benefits of MABR and wastewater treatment process, let's look inside the technology itself. So MABR is basically the most efficient way to introduce oxygen to wastewater. As you all know, this is the most important design factor in any treatment plant, and it's the most energy consuming part as well. Around 1% of the USA's total electricity consumption is used for wastewater treatment. The dashed line that you see on the left side represents the membrane. The MABR spiral, let me just put maybe a marker here. It'll be easier to show. Okay. So on the left side, you can see a circle with brown and blue side. That's the MABR membrane. The dashed line is the membrane itself, and it transfers only oxygen from one side to the other side. The right side, the air side of the membrane, which you can see, only has air flowing through it. It's a very low pressure air flow, only 50 millibars, and the air comes from a process blower and vents out to the atmosphere. Think about driving water through a 4-meter water column and losing all that head on the fine bubble diffusers. And you can understand where the energy savings come from. So oxygen naturally diffuses from the membrane, which is watertight and gas permeable. The left side, the water side, has a thin biofilm starting to develop and taking ammonia from the raw wastewater and oxygen diffusing from the membrane interior. Nitrification starts occurring, and the end product of nitrate diffuses from the biofilm out to the raw wastewater. Now, you typically have high BOD and a lack of oxygen in the bulk wastewater, and that helps denitrification to happen. So altogether, you get simultaneous nitrification and denitrification happening in one basin at a fraction of energy that is used in the traditional system and in half of the volume, as I said. MABR was chosen by GWI in 2019 as one of the top 10 water tech inventions of the decade. And Fluence today has over 200 sold plants based on MABR throughout the globe. Many of them are in Asia. On the bottom left, you can see some of the firms we have cooperated with and provided solutions to. So what does the typical plant look like? A typical MABR plant starts out with pretreatment, coarse and fine screening, and equalization if required. That's also where the only pump in the system exists. Wastewater flows to the MABR chambers, providing the complete secondary treatment and nutrient removal. Most of Fluence's products use MABR in the IFAS configuration, using clarifiers for solid separation and returning the solids to form mixed liquor. Clean effluent can then be disinfected and directed to discharge or tertiary treatment and reuse. MABR provides a high degree of nutrient removal, and it does almost all of the nitrogen removal required in the process. So these are actual results from a system installed in Israel, our oldest system to be frank. COD, ammonia, and nitrate are removed gradually along 3 stages containing MABR, and stage 4, you can see on the bottom on the x-axis, is the last stage that is a very small aerobic area just for BOD and some ammonia polishing. During this unit's operation, we also had a nice discovery of biological phosphorus removal. Since the raw wastewater has a high COD concentration and a very low oxygen concentration, a very negative ORP, oxidation reduction potential, occurs. And that induces phosphorus release to the wastewater. As ORP conditions gradually increase, you go from anaerobic to anoxic to semi-aerobic, the bugs start uptaking the phosphorus, and that results in an overall 90% reduction in phosphorus only due to biology. And we see many similar results in our installations, which are all staged to improve the process efficiency. So overall, with reliable nutrient removal, low energy, and fast installation and commissioning, decentralized is where MABR really excels. It fits like a glove. And I'll show you some pictures and installations. So this is a West Grove Ayala Heights residential project in the Philippines. It needed a wastewater treatment solution, and it was scaling up. It didn't have the full flow from day one. So we built a 4-container establishment treating 400 cubic meters per day of very concentrated wastewater. And actually, the plant was ramped up gradually. Tonglu is definitely the #1 in the beauty contest for decentralized plants. This plant in China treats 100 cubic meters per day of tough wastewater in a rural area in China to supreme effluent quality. Luoyang, China is a good example for the complete end-to-end solution provided by Fluence, including all the pretreatment, secondary, tertiary treatment, clarifier, and sludge holding. The micro is the smallest member of the family and also the newest member of the family. We call it the little brother. On the left, it's before the underground installation, and on the right side, it's after the underground installation. This unit can treat up to 5 cubic meters per day of influent, providing the same effluent quality and having all the benefits of nutrient removal by MABR. Last plant, which was our first major plant in China, was a Xiaogan plant done for iTest. iTest is a huge company operating thousands of kilometers of highways throughout China. 2 years ago, iTest selected Fluence as a wastewater treatment supplier for all their wastewater needs. This plant is located alongside a highway service station and treats very concentrated wastewater to a tertiary effluent quality, enriching a local stream. So China is a great example of the successful implementation of the decentralized approach, with over 200 plants sold in the past 3 years. The local need for distributed decentralized treatment, together with the many advantages of MABR, combined a true success story for Fluence, and a true success story for MABR and local communities that all benefit from the high quality reuse water. So thank you all for your time and attention, and I guess we'll go to questions.
Thank you, Mr. Gilad Yogev. Now, we come to the Q&A segment. Mr. Gilad, there's one question from the floor. How do you monitor the NH4 and NO3 ions during the treatment?
Right. So we have an option to control the process through 3, I'd say, distinct approaches. One is through parameter control. That means controlling our blowers and the pumping system to the containers, and that's basically based on effluent sampling. It can be weekly, it can be even more frequent, but it's I guess a more decentralized approach. The second, I guess, approach is according to the dissolved oxygen. So we have an algorithm to control the dissolved oxygen and maintain conditions that are proper for simultaneous nitrification and denitrification. And the last, I'd say, the most high-end approach for controlling the process is combined dissolved oxygen and ammonium nitrate sensors, which through our control algorithm modify the aeration and the mixing frequency of the MABR modules to provide the right amount of nitrogen removal that's needed to meet the regulations. And that way you don't over aerate the water and sort of, I guess, waste energy when it isn't needed.
Okay, this same question from Mr. Sankar Babu. He requested recommended method also better to mention. You have any better recommended method, Mr. Gilad?
Do you do time-based maintenance or preventative predictive maintenance for your systems?
Yes, for the to monitor the NH4 and the NO3. ions during the treatment?
Yeah, I think it's also a more general question for the plant itself. So we have an app developed specifically for the spiral plant. That app actually is combines a site walkthrough and is also connected to a centralized control system. So if you have 3, 4, 5 plants, that hub, that dashboard can show you the status of all the equipment in all plants, and also show you sort of give you a maintenance schedule. So there isn't any, I guess, sophisticated predictive maintenance algorithm implemented inside the systems. It is in our plans to have predictive maintenance on our equipment. But having said that, there isn't that much equipment to maintain. There are 2 blowers. One is extremely small, and we call it a fan, and the other one is a 4 kilowatt blower for mixing. They both operate intermittently, so you basically have to, I guess, on your site maintenance, walk through, visually inspect that everything's working fine. And that's pretty much it on the maintenance side. I can share a sample report with you.
Thank you.
So, okay, I'm reading the questions here on the side. So I see.
There's another
industrial
question.
water.
From Sanjit. From maintenance point of view, do you do time-based maintenance or preventive and predictive maintenance for your system? If it is the latter, please comment on it.
Yeah, so I just answered that question.
Okay.
I'd go to the industrial wastewater question. So industrial wastewater, it depends on what wastewater. Okay, if there's nutrient removal involved, if there's nitrogen removal involved, and phosphorus removal, we're in the game. We have a great application that's called SideStream. It's if you look up SideStream treatment in Google Scholar, it's sort of the buzzword in wastewater treatment for the past 2 to 3 years. Basically, it's removing a huge nitrogen load from wastewater in order to reduce the burden, either on a municipal plant or on any other industrial plant, right? That has to get rid of the nitrogen. Those plants usually get rid of the BOD very easily and have a difficult time doing nitrification and denitrification. So nitrogen removal for the industry is something that we definitely can do. Sludge management. Sludge management is always a great question we get from when we present a decentralized concept. So the question is, how do you manage sludge from decentralized systems? And that's the answer, I guess, is I can give an example from Israel, where we have most of the land, most of Israel is centralized as Singapore, but we also have some small plants that collect their sludge and dispose it to a designated sludge treatment facility. Now that facility, if you design it smartly, can be in a side area, right? Not in the middle of the whole population, and can actually provide a more efficient sludge treatment process and return fertilizer to whomever is needed, or do various sludge treatment methods such as incineration, or you can make an industry of it, meaning to say. So sludge is basically a product, right? Not a burden. And when you treat sludge in a centralized sludge treatment plant for 10, 15, 20, 50 decentralized plants, you can benefit from the sludge as a product and not treat it as a burden when you look at that. Specifically, Fluence can provide any degree of sludge treatment. We tend to, because we're looking at small plants, we tend to collect the sludge, stabilize it, and then basically it's disposed to a treatment site. I'm going through. Yes, Mr. Young. Want to add something?
Morning.
Your sound isn't that well, Mr. Young.
Bit louder, I guess.
No, I still can't hear you well. Seems to be some problem.
Okay.
Mr. Young, your side is echoing and intermediate. So I suggest we bring the replies to all the questions. We have a lot of questions flooding from the floor audiences. So I suggest that we will actually reply to them separately on emails. Is that all right?
Sure thing.
Okay.
Yeah. If we get a question summary, we'll reply to everyone, of course. Yeah.
Yeah.
I was starting to read the list and it was growing. Okay.
Yeah, but anyway, Mr. Gilad, can we take in one more last questions? Yeah, I think you can see a lot of questions coming in. Probably you can answer one last one, whereas we will send the responses for the rest in separate emails. Yep.
Okay. I take the question about the membrane for the MABR. So we use a gas permeable membrane. It's a market available product. Won't get into the composition because it really isn't of interest, and I probably won't tell you the full composition anyway. But it's a flat sheet membrane as opposed to other MABR suppliers. And it has a high quantity of oxygen transfer efficiency or ability. And the lifespan for the membrane is over 20 years. If you usually tend to mix MABR with MBRs. And when you think about MBRs, it's like a 5-year lifespan. But MABR doesn't do any physical separation. It only transfers oxygen, gas. So we expect a lifetime of over 20 years and guarantee the product for 15 years, prorated guarantee. So that's a guarantee we give on MABR membranes. It's 3 to 5 times more than your other membrane technologies available in the market.
Thank you, Gilad. Gilad, can you send the video link which we were unable to play earlier in the chat so that everyone can
Sure.
access the video?
Sure thing. Let me hold on that for a minute.
Yeah, meantime, over to Lily for the next presentation.
Okay. For any unanswered question, we'll respond in a separate email. Once again, thank you, Mr. Gilad.
Thank you.
We look forward to all attend our upcoming webinar on 13, 28, and 29 January 2021. Thank you all for your participation. Please contact SWA Executive Office for any further queries. Stay safe, stay well. Goodbye.
Please stay on for the video link. Thank you.